Hello, my name is Adam Califf. My partners are Jacob Valdez, Payne Parrish, Kennedy Moizoiti, and Chance Huddleston. Our project, Desperado AI, is being developed for CSE 3310. Chance?
Thanks, Adam. So I'm going to go ahead and do a front-end walkthrough of our base app right now. A lot of it's pretty basic, just to have the functionality going first, and then we'll come back in and work on the UI, make it pretty and all that. So far, this is our login page. Right now, we don't have our databases set up, but in the future, we will have back-end checking for when the user enters their information. We'll be able to check if they've made an account with us, and if not, then they can sign up. So we'll go ahead and go into the app right quick. So this is our landing page. As you can see, it just starts right into the conversation. Any previous conversation that you've had is stored locally on the phone, which is what we're really excited about on this project. We can go ahead and go into the account management right quick. So like I said, we're still into the base kind of bones of the application. This is where you can manage how your data is stored and how much data you want to share, and basically all your privacy settings, and as well as your personal information that you may or may not want out in the world. And then we have our settings fragment, which is where you'll modify the chatbot itself. And then we have our top right. Oh wait, weren't we supposed to remove that part? That top right section?
Yeah, I'll clip the part of the video. Just move on.
All right. So for the framework of our project, I'm going to go ahead and pass it off to Kennedy right quick so he can get back into the back end of our project.
All right. Let me go and share my screen. Y'all see that okay?
Mm-hmm.
So on the back end of the project, I'll go ahead and take a look at the Java files that we have. So concerning with the login, so it's intended that we're going to implement a way to check if a user is logged into the app. We've created a series of functions. As soon as they click the login button, we're going to create a way to check a database of users, of valid users, and if it's a correct user, then they're granted access to the app. Otherwise, it'll send them to a sign-up page so they can create an account and then begin using the app. And the sign-up button will also push them to that sign-in page. We're also going to create a database, a local database on the app, which we're going to use to store the login information. Also, we're going to use the database helper to also store versions of the conversation model as it's getting trained as the user interacts with it. So as we were building this app, we used Android Studio, their inbuilt functions to create little activity mains, so we didn't have to do everything from scratch. It made the whole startup process, as we're learning, a lot easier. Let's see here. So we just create a activity login. We drag from the palette images, buttons, text fields, and then just style it in the way that we want it to. And then from there, we create our Java files and handle the interactions or how these would be interacted with the human, or how they interact with the human. So yeah, so from here, I'm going to go and pass it to Jacob so he can explain the conversation model of the app.
Thanks, Candy.
Anything?
Now, you notice in the demonstration that we didn't show off the actual conversation with the user and the AI. And that's because right now it's still under development. We haven't yet put the AI into the Android application. What I want to do is show you the backend where our AI is being developed. And we take advantage of the free environment that Google's provided, Google Colab, to develop the AI. Let me move over there. Now, Google Colab gives you a Python execution notebook environment. And here you see we use TensorFlow along with TensorFlow datasets and transformers, which is a Hugging Face Python API, to develop the backend. We only use transformers for the tokenizer. We branch off the Distill BERT tokenizer, has a little over 60,000 tokens, so that is sufficient for a mobile application. And then we take two datasets. First, we take an empathy dataset that was released by Facebook in their famous Blender bot AI. And we also take a conversation dataset from the famous TV show Friends. Those two datasets are used to train the neural network to represent sentences as a single vector. Now, you may ask, how is that possible? How can you take words and turn them into numbers? Well, obviously, you can take a word and for every different word in the English language, give it a different number in the integer space. And we do that. But you know, we want numbers that would represent an entire sequence of elements. So if you were to ask some number, what do you know about, let's say this number represented the word the. If you ask that number, what do you know about the words that are around you? And that number would not know anything. Just illustrating it, by the way. But if you pool the numbers, run them through a neural network, run them through convolutional, transformer, attention layers, by the top of the neural network, those numbers know quite a bit about what their neighbors represent, and they carry a good degree of mutual information about the content behind them. So we apply that principle when it comes to an encoder-decoder architecture. We use the famous transformer architecture combined with an LSTM, and they both have their benefits. LSTMs are more time-aware. Transformers, they have the problem of symmetry breaking and representation collapse. But together, we find that they're an effective strategy for representation. You can see our loss plot goes down over time. We have yet to take qualitative samples. Just to really emphasize the key point about this architecture, what we do, so here's what we're not doing. We're not taking a sequence of elements, and we're not just going straight sequence to sequence. What we're doing is we're doing sequence input, turn that into a vector, and then compute a new vector from that vector, and then compute the output sequence from that vector. So you have the user makes a statement, that user statement is converted to a vector, then this vector is converted to another vector, and that another vector, it goes back into a text representation of the AI's response. But here's the big deal. This vector to vector up here, that's just a single matrix. And we believe that the entire traditional conversation space can be modeled as a Markov decision process. If we do that, we can use a single matrix. We have very simple, low weight, low variable count for a high complexity model. This allows on-device training of conversational models, which is really the killer feature of our application. It has not been widely adopted. It'll probably be another year before TensorFlow or the NN API gets it. We are doing on-device training with each user's personalized statements to make personalized responses. On the back end, we're not just using gradient descent, but we're actually using a Hopfield neural network, which has the characteristic of scale symmetry, criticality, and it doesn't have the catastrophic forgetting problem. So these are very important features when developing any conversation AI, and we believe that it will make our application stand out from all the others. Now, we will have a working demonstration by Monday. I hope to share it with you, and I want to thank you for taking the time to watch our project's presentation video.